Hello everyone, myself is Vigneshwari, Assistant Professor in the Department of Electronics and Communication Engineering from SNS College of Technology, Coimbatore. So today we are going to see the topic on 8085 architecture. This comes under the unit 8085 and 8086 microprocessor and the subject 23ECT221 microprocessors and microcontrollers. So why do we need a microprocessor? So before microprocessor, systems were mostly manual. So manual control is slow and always prone to errors sometimes. So microprocessor brought automation, fast decision making and accuracy. So 8085 microprocessor is a 8-bit processor developed by Intel, and this processor is widely used and in simple embedded systems such as early washing machines and also in traffic signal controllers. So what is 8085 processor? So 8085 architecture, this refers to the internal organization of the microprocessor, right? It shows how different units like arithmetic logical unit, registers and control units, they have been developed and wholeformly how this architecture functions. So it contains the different units like arithmetic logical unit, registers, control units and buses. All these units are connected and coordinated. So understanding the architecture helps us know how instructions are fetched, decoded and executed inside the processor. So let's now see the major blocks of such microprocessor. So the main blocks of the microprocessor include CPU, timing and control unit, registers, arithmetic logical unit, interrupt control and bus interface. So each block has a specific function, but all blocks work together to execute a program step by step. So first let us see with the central processing unit. The central processing unit is the core of the microprocessor. So it is responsible for processing the instructions and controlling the system operation. The CPU contains ALU, registers and control logic. So whenever a program is executed, the CPU decides what operation to perform, when should perform and where the data should move, right? So the CPU acts like the brain that coordinates all the activities inside the processor. So next comes with the arithmetic and logical unit. So the arithmetic and logical unit, or simply we say as ALU, this performs all the mathematical and logical operations. Arithmetic operations include addition, subtraction, increment and decrement, and logical operations include AND, OR, XOR, complement and comparison. So the ALU always works with the accumulator. So after every operation, the ALU updates the flag register which indicates the result status such as carry, zero, sign, parity and auxiliary carry. So this helps the processor take decision like branching or it is of a looping. So this is how the arithmetic and logical unit functions. Next comes with the accumulator. The accumulator is the most important in 8085 because it stores the operand before an operation and the results after the operation. So almost all the ALU operation involve the accumulator. So that is why it is often called the heart of the microprocessor. So without accumulator, the data processing is not possible here. Next comes with the general purpose registers. So these registers are used to temporarily store the data during the program execution, and they can be used individually or as a register pass. So the register pass such as B, C, D, E, H, L. So these are the very important register pass. So the HL pair is a special because it often acts as a memory pointer. Using registers reduces memory access, which improves the execution speed. Next comes with the program counter. The program counter is a 16-bit register and where it stores the address as well as of the next instruction to be executed. So after an instruction is fetched, the PC is automatically incremented. So next comes with the stack pointer. The stack pointer is also a 16-bit register. It holds the address at the top of the stack. The stack is used during function calls, interrupts and temporary data storage. In the 8085, the stack grows downward in the memory. Next comes with the flag register. The flag registers, it stores the status of the ALU operation and it comprises of 5 flags such as carry, zero, sign, parity and auxiliary carry. Next comes with the timing and control unit. The timing and control unit is a sequence of timing of all the operation where it could generate and control signals such as read, write as well as enable. And next comes with the bus interface unit. The bus interface unit, it allows the 8085 to communicate with the memory and IO devices. So it manages address bus, data bus and control bus. The address bus is a 16-bit and unidirectional. Data bus is 8-bit and bidirectional, whereas the control bus carries the timing and control signal. Next comes with the application. The 8085 is used in the traffic control system, temperature controllers and simple automation. So its simple architecture makes it ideal for learning and basic control application. 8085 is used in traffic control system, temperature monitoring system and basic automations. Its main advantage is its simplicity, but it has limitations such as slow speed and limited memory. The main function of ALU in 8085 is to perform arithmetic and logical operation. And the register pair which act as a temporary data holder for ALU is it is the register pair is a PC. So with this we'll conclude today's session of 8085 architecture. Thank you.